Welcome to True Projects. In this video, we are going to explain about the project, which is securing IoT data in the cloud with the blockchain technology. Introduction. The primary focus of this project is to significantly enhance the security and privacy of Internet of Things, which are IoT data, when they are stored in the cloud. This endeavor acknowledges the growing importance of IoT in various domains, and it aims to address the critical challenges associated with securing vast amount of data generated by IoT devices. Traditional methods for securing IoT data heavily rely on data encryption, which while effectively falls short in the IoT context due to centralization, vulnerabilities, and limited privacy measures. These shortcomings can lead to single point of failure and unauthorized access, while also risking undetected data alterations undermining the integrity of IoT data. To address the shortcomings of traditional methods, this project introduces an inventive approach that makes full use of blockchain technology's built-in features to tackle these challenges comprehensively. Blockchain is a distributed and decentralized digital ledger technology that records transactions across multiple computers in a way that ensures the security, immutability, and transparency of the data stored. It operates a chain of interconnected blocks where each block contains a list of transactions, and once a block is added to the chain, it becomes virtually impossible to alter the data it contains, providing a tamper-proof record of information. In this project, we harness Ethereum's robust smart contract capabilities within the blockchain to enhance IoT data security, privacy, and integrity. This includes implementing decentralized access control and authentication of users. Objective of the project. The project's goal is to showcase the real-world applications of blockchain technology in the cloud services, creating a secure, decentralized, and tamper-proof ecosystem for storing and retrieving IoT data. Blockchain technology is harnessed in this project to establish decentralized by distributing IoT data across multiple nodes and ensuring data integrity through unique hash codes for each transaction. SHA-512, which is a secure hash algorithm 512-bit, is a cryptographic hash algorithm that is part of SHA-2 family of hashing algorithms. It takes an input data and produces a fixed size 512-bit, which is 64-byte hash value. SHA-512 is known for its high level of security and resistance to cryptographic attacks. SHA-256 is used to protect IoT data and use passwords with encryption. Its benefits include resistance to brute force attacks, ensuring that data remains secure and tamper-proof, and providing a reliable means of checking data integrity, which is crucial in an IoT data storage and access system. Requirements of the project. We need hardware and software requirements. Coming to hardware requirements, we need processor of 5 and above, RAM of 8 GB and above, ROM of 25 GB and above. In software requirements, we need Node.js, Python of 3.7.0 version, and Visual Studio Community version. To implement this project, we have designed various modules in the methodology. The first module is Simulation Application. This application simulates IoT data collection, specifically generating random temperature readings as a representation of data from IoT sensors. The generated temperature values are then securely stored within the blockchain system. Each simulation temperature reading, along with its associated timestamp and SHA-512 hash code, is recorded in the blockchain, demonstrating how IoT data can securely stored and verified for integrity. Coming to Flask Service Web Application. This web-based application is built using Flask and servers as the user interface for interacting with the IoT data stored in the blockchain. In this, we have sub-modules. The first one is New User Sign-up. Users can register for an account within the simulation application, enabling them to access and utilize the IoT data simulation features. Next module is User Login. After registration, users can log into the simulation application using their credentials. In this, we have a sub-module, which is Access Blockchain IoT. This allows users to select and view IoT simulation temperature data securely stored in the blockchain. This feature provides user-friendly interface for accessing and verifying the data, ensuring data integrity and security. Blockchain integration. Blockchain technology is used to securely store IoT data in the form of transactions or blocks, with each data point associated with a unique hash code for a tamper-proof storage. Unique hash codes associated with each transactions in the blockchain ensure data integrity. If any data is altered, hash code mismatches occur, allowing for a rapid detection of potential security breaches. Blockchain's inherent features are leveraged to provide secure access authentication for users, ensuring that only authorized individuals can access to IoT data. Ethereum, a blockchain platform, is utilized to deploy a Solidity contract. This contract contains functions for storing and accessing both user and IoT data, demonstrating the practical implementation of blockchain within cloud services. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files. These files contribute to the visual and interactive aspects of the application. This is the templates folder. This folder contains all HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. This is the main.py file. This file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. Now we need to open the HelloEth folder. This is the node module folder. This folder contains dependencies or modules needed for our project. Now we have to open it. This is the bin folder. This folder contains executable scripts related to the project dependencies. Now we have to open it. This is the run blockchain.bat file, which is Windows batch script to start the blockchain. This script will initiate the local Ethereum blockchain for development purpose. Now we need to double click on it to start the blockchain. Blockchain will be hosted on the local machine at the address, which is localhost, and the port. This address allows us to interact with the various tools of the blockchain and applications. So here we need to execute the command, which is truffle space migrate. Now we need to click on enter. This will compile and deploy smart contract. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. After running the migration, we will receive a unique contract address. So this is the unique contract address. This address represents the location of our deployed smart contract on the blockchain. And here we have gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now we need to minimize it and get back to the main directory. This is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file to execute the project. Now we need to double click on it to execute the project. This is the user interface of the project. With this, we can interact with the program. Now we need to click on Start IoT Simulation to generate IoT devices. So here, each circle represents one IoT device. Whenever any sensor sends the data to blockchain, its color will change to red. In the text area, we can see that sensors are sending data, and we can see its time, SHA-512 hash code also. In this process, at any time, we can stop the simulation to stop sending the data. So now I will click on Stop Simulation. Simulation has been stopped. Now we need to click on this button to get blockchain transaction storage time graph. So I'm clicking on this button. So here on the x-axis we can see the data sense number, and on the y-axis we can see time nanosecond for blockchain transaction storage. Now we need to close this. Now we need to get back to the code folder. Now we have to click on Run Flash Server to start the Flash server. Flask has hosted the application locally at the default address, which is localhost, and the port. Now we need to copy this local link provided by the framework and paste it in any browser. So I'm copying it, and now I'll paste it in the Google Chrome. So here I'll paste the link. At the end I need to type index, and now I need to click on enter. So this has redirected to the web page of the project, which is displayed in the browser. Here we can see in the home page two links, which are user login here link, new user sign up here link. So as the user has not signed up, for that first we need to click on New User Sign Up Here link. Here we need to give the user details, which are the username, password of the user, contact number, email ID, and the address. Now we need to click on Submit. So here we can see that user sign up task has been completed. Now we need to click on User Login Here link. Here we need to provide the credentials of the user, which are the username and the password. Here we need to give the password. Now we need to click on Login. Here we have the two links, which are Access Blockchain IoT and Logout. So first we need to click on Access Blockchain IoT link. So I'm clicking on this link. Here we need to select the IoT ID. So I'm selecting the IoT ID as 3. And now I need to click on Submit. Here we can view the IoT ID details, which are IoT details. So for IoT ID 3, this is the sense temperature and sense time. And here we have the SHA-512 hash code. Now we will choose another IoT ID. So I'm choosing IoT ID 4. And now I'll click on Submit. Here we can see for IoT ID 4, sense temperature, sense time, and SHA-512 hash code. In this way, we can use simulation screen to generate temperature values and they can be stored in the blockchain. Then, using Flask web application, user can access that data. Now we will close this GUI, which means logout. Conclusion of the project. The project successfully enhances the security and data integrity of IoT data in the cloud through blockchain technology. Blockchain implementation decentralizes data storage, mitigating the risks associated with the centralized systems. This project prioritizes user access authentication, ensuring that only authorized individuals can interact with the IoT data. This project showcases the practical implementation of blockchain with the cloud services, providing a foundation for future innovations in securing sensitive data.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.